Good morning. Today I have come up with a very interesting series of video in which I am going to cover the important formulas required for the GATE exam. So you see, basically in GATE exam, the most of the question is numerical based, with around 70 to 75% we have numerical and 20-25% there is theoretical question. So for numerical questions, one of the most important thing is that you should remember the formula. Now for many students, they know the concept, but in meanwhile during the exam they could not recall the formula. As a result, even though while knowing the questions, they are unable to solve the problem and get the answer. So first of all, in this class I am going to discuss formulas of basic gas power cycle. So what you see here is a gas power cycle. The gas power cycle works on Brayton cycle, and here we have four cyclic processes are there. From 1 to 2, from 1 to 2 there is a compression, so here work will be required. From 2 to 3 there is heat addition at constant pressure. From 3 to 4 work gas is expanding, so we get work output, that is WT. And 4 to 1 heat rejection at constant pressure take place. So this is the graph in TS curve. Similarly, we can plot this graph on PV curve. Now we comes to the formula. Here first one is the back work ratio. It is given as the ratio of negative work by positive work. Here the negative work means the work which is given to the system. For in gas cycle we have a compressor, so we have to provide work to the compressor, so negative work will be WC. In case of steam power plant, pump is used, so WP divided by the positive work is the turbine work, because here the work we get out of the system which is taken as positive, hence WT. Now work ratio is equal to 1 minus back work ratio, or simply we can say that the work ratio plus back work ratio equal to 1, that is equal to net work by work done by the turbine. Now we come to the efficiency. Efficiency of a Brayton cycle is given as 1 minus 1 by Rp, which is pressure ratio whole to the power gamma minus 1. Pressure ratio is the higher pressure by lower pressure, that is P2 by P1. Here we have denoted the higher pressure with P2 and lower pressure with P1. Now there are two cases. First case is that what should be the pressure ratio so that we get the maximum work output, and the second is the pressure ratio to get the maximum efficiency. So for the maximum work ratio, the T2 and T4 temperature are equal, and which is equal to the under root of T1 T3, and the formula for the optimum pressure ratio is T maximum by T minimum whole to the power gamma by 2 into gamma minus 1, where T max is T3 and T min is T1 according to this figure. Okay. Now the maximum possible work output is given as W max equal to Cp into root under T max minus root under T min whole square. It is per unit mass basis. If we have to calculate total work done, not a per unit mass basis, so we have to multiply with the mass, and if the mass rate we multiply, then we will get the power output. Now we come here, optimum pressure ratio for maximum efficiency, which is given as T max by T min whole to power gamma by gamma minus 1. Now specific fuel consumption, it is given as the 3600 by W net, where W net is in kilowatt, and unit of specific fuel consumption is kg per kilowatt hour. Now many times we see that the expansion or compression process is not isentropic, rather there is a deviation. So if the isentropic efficiency point of view is considered, then we will calculate the isentropic efficiency of turbine or compressor. For turbine, it is given as the isentropic work by actual work. So for turbine, the isentropic work will be from 1 to 2, but the actual work will be from 1 to 2 dash, which is more than the isentropic work. Hence, the isentropic efficiency of a turbine is given as isentropic work by actual work, which is equal to H2 minus H1 by H2 dash minus H1. Similarly, for turbine, we see that the actual work is actual work is less than the isentropic work. Hence, the efficiency of turbine isentropic efficiency of a turbine is given as actual work by isentropic work, which is equal to H3 minus H4 dash, which is the actual work, by H3 minus H4, which is the isentropic work. Now, to improve the efficiency of the gas power cycle, regeneration is done. Regeneration is basically we use here a heat exchanger in which the hot flue gases which comes out from the turbine at T4 is allowed to pass through heat exchanger, where it exchanges heat with the cold air which is coming out from point 2. Okay, so for ideal regeneration, TB, which is the temperature from where the heat addition start, will be equal to the T4, and T2, which is the outlet of the compressor, will be equal to the TA, which is the outlet from the turbine after the heat outlet of the heat exchanger. Now, efficiency of ideal regenerative cycle is given as 1 minus T1 by T3 Rp to the power gamma minus 1 upon gamma. Similarly, we do reheating in gas power cycle to get more work output. Here, efficiency is improved or not, that will depend upon the situation, but definitely one thing is there, that we will get more power output. So for perfect reheating to obtain maximum work, T3 equal to T5, T4 equal to T6, and Pi equal to under root PH, and the work done in both the turbine will be equal. Intercooling. To reduce the compressor work, we provide with intercooling stage. Here the total work is reduced, and the temperature at the outlet of the first compressor will be equal to the temperature at the outlet of the second compressor, that is T1 equal to T3, and the temperature at the this is the inlet of the first compressor will be equal to temperature at the inlet of the second compressor, and temperature at the outlet of the first compressor will be equal to the temperature at the outlet of the second compressor, that is T1 equal to T3, T2 equal to T4, and intermediate pressure will be root under pressure higher into pressure lower, and in this case the work done by the compressor 1 will be equal to the work done by the compressor 2. So these are the some of the basic formulas of gas power cycle, and in next class we are going to discuss some of the basic formulas, important formulas of Rankine cycle. So thank you very much.